Hello everyone and welcome to my YouTube channel. Today we are going to look at this question. It's a November 2014 question. And the question reads, beam ABC is built in at A and C and supported on rollers at B as shown in figure 1. Analyze the beam using the moment theorem and show the bending moment diagram indicating all the critical values. So for span AB is 5 meters. You have a point load of 20 kilonewtons. Then span BC is 4 meters and you have a UDL of 10 kilonewton per meter. Then for span AB, the moment of inertia is 2I. For span BC, the moment of inertia is just I. So I have withdrawn the question, but before that, we're going to look at 3 steps in solving this question. Step number 1 is calculate the sagging moment. Step number 2 is calculate the bending moment and the X bars. That is calculate bending moment areas and X bars. Then step 3 is apply the 3-moment theorem equation in getting the support moment. So I've redrawn the question. It is here. For better clarity, you can see span AB, you have 2 meters and 3 meters. You have a point load of 20 kilonewton meter. Then span BC, the one I'm pointing here, has 4 meters and the moment of inertia is simply I. So let's go straight to step number 1, calculate the sagging moment. So we'll start with span AB, this span here, AB, this span here, that one, span AB. So the formula for calculating span AB is WAB over L. So if you work out that, you'll get it 20 this point load multiplied by our A is the distance from here to here, which is 2 meters times 2, 10 times B is the distance from this point load to support B is 3 meters. So 20 times 2 times this divided by 5. If you work out that, you'll get 24 kilonewton meter. For span BC, the formula for calculating the sagging moment is WL squared over L. So W is our UDL, which is 10, and the L is the span, which is 4 meters. If you work out that, you get 10 times 4 squared divided by 8, which will get to 20 kilonewton meter. So the next thing we do now is to sketch the bending moment diagram. And if you sketch, since this is for span AB is a point load, the shape of the bending moment will be a triangle. And for span BC, since it's a UDL, it's going to be a parabola or a curve. The values, we will get the values. This one is 24 kilonewton meter, and this one is 20 kilonewton meter. So now we proceed to the next step, is to calculate the bending moment areas and the X bar. So we'll start with span AB. So the area for span AB is basically the area of this triangle is a half base times height. So a half, our base is 5, the distance from A to B. Then our height is the value of the bending moment is 24. Work out that, you'll get the value is 6. Now, for this question, which has 6 supports at A and B, for us to apply the 3-moment theorem equation, you have to imagine an imaginary span. So for that reason, we'll imagine an imaginary span on the left side of A and also an imaginary span on the left side of C. So for that reason, we are going to have 2 X bar, that's from support A to B and from B to A. So for X bar left, you have the formula A plus L divided by 3. Our A in this case will be 2 and our B will be 3. So our A is 2, so 2 plus L, that is 5, will get 7 divided by 3. So our X bar left will be 7 over 3. So our X bar right, if we are moving from B to C, we'll get the same, but now the formula changes here slightly. We'll use B. Our B is 3 plus L divided by 3 is 8 over 3. So the next span, we go to span BC. So the area of a parabola is 2 over 3 times base times height. So our base is 4 and our height is 20. Work out that, we get 160 over 3. The next parts are the same, whether you're moving from left or right, since the parabola is symmetrical, and you'll get it is basically 4 divided by 2, which is equal to 2 meters. So as I had indicated earlier, we are going to assume an imaginary span so that we can apply the bending moment theorem equation. Okay, so let me grab this. Okay, so we are going to imagine a span on the left side of A, so that is A naught A, and we'll start with that. So we apply now the bending moment theorem equation. Which we'll call this span A naught A. So to apply the bending moment, the 3-moment theorem equation, we'll have MA L naught divided by I plus 2MA L naught divided by I naught plus L1 divided by I1 plus MB L1 divided by I is equals to -6 A naught X bar naught divided by I naught L naught plus A1 X bar 1 divided by I1 L1. So this value is 0, since this is just an imaginary span. And again, this value here is also 0, and this one is also 0. So basically, this one is 0, or basically this is 0, and also this is one is also 0. All right, it's important to know that. So if you do that, this equation is going to reduce. So if you work out, you'll get 0 plus 2MA plus 0 plus 5 over 2I. Remember, for span AB, the moment of inertia is 2I. So we get 2I. Then for this, we get 5MB, because our L1 is 5 divided by 2I is equals to 6. It's equals to -6. Into bracket is 0 plus our A1 was 60. Our X bar 1. Remember, we are going to use X bar right. X bar right. So we have to span. Remember, let me go back and show you where that is. We are going to use X bar right, not X bar left. I see most of the students confused. So it's X bar right, that one, this one. From this side to this side, we are going to use 8 over 3, this value here. So I see most of the students confused that and they get it wrong. So if you work out that, the equation now further reduces to 0 plus 10, if you open the bracket here, 10MA over 2I plus 5MB over 2I equals to -6. you work out this, you get this. So if you simplify the equation further, if you multiply throughout by 2i, so this will reduce to 10 MA plus 5 MB is equal to negative 192, and that will be our equation number 1. So now we are going to move to the next span, that is span AB, AB, BC. So again, we apply the three moment equation as MA L1 divided by I1 plus 2 MB into bracket L1 divided by I1 plus L2 divided by I2 plus MC L2 divided by I1 is equal to negative 6 into bracket A1 x bar 1 divided by I1 L1 plus A2 x bar left. Now this time around we are going to use x bar left divided by I2 L2. So if you punch in the values, you get our MA L1 is our L1 is 5, so it's basically 5 MA divided by 2I plus 2 MB into bracket 5 divided by 2I plus 4 over I, right? Our I2 is I plus 4 MC. I2 is basically I equals to negative 6. A1 is 16. We have already calculated that. X bar 1, this is x bar left, x bar left, which is 7 over 3, divided by I1 is 2I, and of course L1 is 5, plus 116, that is x bar 2. No, so that is A2, multiplied by x bar 2 is basically 2, divided by I2, I, and L2 is basically 4. So if you simplify that equation further, I will get here is 2.5 MA divided by A plus 13 MB divided by A plus 4 MC over I equals negative 6, 14 divided by A plus 26.67 divided by I. So if you multiply throughout by I, this equation will be further to 2.5 MA plus 13 MB plus 4 MC is equal to negative 244, and that forms our equation number 2. So now next we are going to go to the next span, that is span BC and C naught. This equation here, BC C naught. And if you apply the three moment equation, you will get this. Again, the value of L naught over I naught is 0 because it's basically an imaginary span. Again, this value again will also be 0. Also, this value will be 0. In other words, now what I'm saying, this one is 0. This one will also be 0. And this small part will also be 0, since this is an imaginary span. Okay. So if you simplify this equation further, you will get 4 NB over I plus 2 MC into bracket 4 over I plus L naught over I naught plus MC L naught over I naught is equal to negative 6. Our A2 is 160 multiplied by 2 divided by I times 4. And of course, this A naught, X naught for this span over I2 over N2. Then if you simplify this equation, I've already told you this one is 0, this one is 0, you get this equation. 4MB plus 8MC is basically is equal to 160. So you can even ignore this 0. So now, let me wrap this. You have the three equations. You need to solve these three equations and get the values of MA and MB. So if you solve this simultaneously, or if you solve this simultaneous equation, you'll get the value of MA, MB, and MC. You can either use elimination method or statistical method, whichever method you are comfortable with. So I'm now going to show how you solve that. I'll go straight to the answer. If you solve that simultaneous equation, you'll get that MA is negative 13.25, MB is negative 11.89 Newton meter. So this is supposed to be MC. I made a mistake now. So this one is MC, sorry, this is MC, MC. And MC is negative 14.05 kilonewton meter. So the next thing we are going to do, we are going to plot both the bending moment, the sagging moment, and the hogging moment, okay? And see how the diagram is going to look like, right? So the sign convention that is used is that sagging moments are positive, and hogging moments are negative. So the sagging moments were already calculated. We already calculated this value 24 and this 20. The support moment or the hogging moment is what we were calculating using the three-moment theorem, and we have gotten MA is negative 13.25, and come and plot it here. MB, the obscenity is negative 11.89, to come and plot it here, and MC is negative 14.05. So the sign convention again for hogging moment is negative, as shown here. For sagging moment is positive. So this is how the bending moment diagram looks like. And that's how you solve that equation and you get all the 20 marks. Thank you. Don't forget to like this video, share, and subscribe.